right, number 21 asks us to find the domain of the function, and it also asks us to find any zeros. Now, these are two different questions. When we're looking at the domain, we need to look at the denominator. Okay, so if I have t squared minus 9t, the domain is basically going to be any real numbers except there may be something that makes the denominator 0. So what I'm looking at is where is the denominator 0. Okay, so here it's the denominator that's equal to 0. So if I set it equal to 0 and solve it, I'll find out any places what t's I could plug in that would make it 0. So you basically take the denominator, set it equal to 0. So I could say, well, I could factor out a t out of t squared minus 9t, and that would leave me t minus 9. So I have two things that multiply to get me 0. One of them is t, so I set it equal to 0. And the other thing is t minus 9, so I set it equal to 0. So I can tell I can't let t be 0. So this is one thing I can't do. And the other one is, let's solve for this other t. I could add 9 to both sides, and I get t equal 9. So it can be all real numbers except t equal not 0 and t cannot be 9. Those two numbers would mess it up. If you go plug it in and check it out, sure enough, both of those numbers, if you plug them in the denominator, would make it 0. So usually we write our answer, we just actually, for the domain, here's how usually I would really write my answer. It would be all real numbers, t equal not 0, t equal not 9. Okay? Now what about the zeros? The zeros are the solutions, and they're where the numerator equals 0. So the domain, you could use anything except for things that would make the denominator 0, and for the zeros, we're going to set the numerator equal to 0 and find out where those solutions would be. So for the zeros, this is part B down here. I would take t squared minus 9 and I'd set it equal to 0. Well, if I look at this, this is a difference of two squares. I could factor this t minus 3, t plus 3 equals 0. So I take each one of those factors and I set them equal to 0. And I solve, and I get t equal 3 from this one, and I get t equal minus 3 from this one. So my zeros are t equal 3, t equal minus 3. I could list them like this, minus 3, 3. Or I could even write them as points. I could say, well, if these are zeros, that means they're x-intercept. That means x is 0, x is 3, y is 0, and x is negative 3, y is 0. And I'm going to look and see what your book does just so I can be kind of consistent here. They just list them in the set notation like this thing that I circled here. Okay? Okay. In 23 we have the problem, and I've written it here, and I drew that line there. I'm just going to draw a line like this. This is the original problem. Now, this problem is equal to writing x to the 4th minus 16. And this x cubed minus 1 to the minus 1, it wants to go to the bottom, to the denominator, so it would just be x cubed minus 1 to the first power, which is just x cubed minus 1. Okay. Now, if I'm looking at what could mess first of all, let's look at the domain. So for the domain, we're going to take the denominator, and we're going to say it's going to be all real numbers except where the denominator equals 0. Okay? So I can put anything I want to in there, but is there a place where the denominator would be 0? Let's check it out. X cubed minus 1 equals 0. Well, let's see. Let me just add 1 to both sides. Where would I get x cubed equal positive 1? If I cube root both sides, I just get one answer. X equal 1. 1 cubed is 1, in other words. So my domain would be all real numbers, but x can't be 1, because if I plug 1 in there, I'll get 0 in the denominator. Okay. Now, so for the domain, I can use anything except places where the denominator would be 0. The next question they're asking me is really talking about, well, what happens when the numerator is equal to 0? When the numerator is equal to 0, we get our solutions. We get our zeros. Remember, anytime you solve an equation, you set something equal to 0, and if you've got a fraction and you set a fraction equal to 0, it's the top part that would be equal to 0. So all I got to do is say, well, what about x to the 4th minus 16? I could factor this. This is actually the difference of two squares. I could factor it, or I could do this. What if I just added 16 to both sides? I could solve using roots here. X to the 4th is 16. Now, what I can do is I can take the 4th root of both sides. Again, I could have factored, but I'm just going to show you a faster way to do it. The cube root of x to the 4th is just x, and then the plus or minus root, 4th root of 16. 2 to the 4th is 16. It's an even root, so I need to put plus or minus on it. So my solutions are going to be plus or minus 2. So for my solutions, if I listed them, I could just put plus or minus 2. Okay, that would be a fast way to work that one. Okay, this is the last one I'm going to do on this video. What about one like this? They still want us to find the domain. Okay, and that means domain, usually I can plug in any real number I want to, except places where the denominator might be 0. So let's look at where's the denominator going to be equal to 0. So I take it and I set it equal to 0 to figure that out. Now if you remember, when we're factoring things and you have an x to the 4th and then an x squared, we can factor it like this. We can say that's going to be x squared and x squared, and then we factor it just like we would if it were x squared plus x minus 2. In other words, I'm going to try to multiply to get the number on the end, negative 2, and add to get the number in the middle, 1. Let's see. 2 and 1, let me do a 2 and a minus 1. 2 times negative 1 is negative 2. 2 plus negative 1 is 1. So this is going to be x squared plus 2 and x squared minus 1. All right, now I can keep factoring because x squared minus 1 is a difference of two squares. This right here breaks down into x plus 1, x minus 1. Okay, so now I need to take each one of those and set them equal to 0. So I said x squared plus 2 equals 0. I subtract 2 from both sides. I get x squared is negative 2. Ooh, if I square root that, that's going to be an imaginary number, so there's not going to be anything come out of that one. But what about these other two? Well, if x plus 1 is equal to 0, I can subtract 1 from each side and get x equals negative 1. Okay? And then on this other one, x minus 1 equals 0. I can add 1 and get x equal 1. Oh, so there are two numbers that would make my denominator 0, negative 1 and 1. So my domain up here is all real numbers, but x can't be, I'm just going to put x can't be plus or minus 1. That's one quick way I could write it. So there's the answer to the domain question. Rows, the solutions, the x-intercepts, what I have to do is take the numerator and set it equal to 0 to find those. Because anytime we solve an equation, we take the equation, we set it equal to 0, and in this case, again, if a fraction is equal to 0, it's only the numerator that would give us the 0 part of that. Okay, so for 27, we have x cubed minus 2x squared plus x minus 2. Okay, so there's 4 terms. I'm going to set them equal to 0. I'm going to factor by group. I'm going to put together this, and I'm going to put together this. Okay, out of the first two terms, there is an x squared that's a GCF, and that would leave me with an x minus 2 when I factor that out. And then over here, I see that I have x minus 2, and I want it to be into parentheses to look like that first one, don't I? Well, what can I do to make it like that? I can put it like that and just put a 1 out front, because that would be the same thing as what I have above, isn't it? So I could just put a 1 times x minus 2. I can go, okay. Now these two terms have a GCF of x minus 2, and then my leftovers are this x squared right here and this plus 1. All right, so let's solve. We're trying to set the numerator equal to 0 to find our solutions. We have our two factors. If I set my first factor equal to 0, I can add 2 to both sides, and I'd get x equal 2. So one of my zeros is at 2. And let's look at this other one, x squared plus 1 equals 0. Well, if I subtract 1 from both sides, I get x squared is negative 1. Now, that's not a real number, is it? Because if I square root both sides, I've got the square root of a negative number. So if I'm looking at numbers and I'm just thinking about real numbers, my only solution here is 2 for number 27. We will talk about the fact that square root of negative 1 actually is, it's called I. It's an imaginary number, but it's not a real number, and it's not on the number line, so I'm not even going to write it as an answer, though I could say it's a root. your book at this point is not talking about, it's not giving you anything with these i's in it yet. It's not gotten to imaginary numbers yet, so right now we'll just leave it like this. In a future section, we would be writing some imaginary numbers down as roots also.